Today, I want to introduce you to the concept of the Sharpe ratio. And the Sharpe ratio is one of the most important metrics in quantitative investing and trading. So first, we're going to learn what the equation is. We're going to see the actual formula and how to calculate it. Then I'll walk you through some code that will actually calculate it in Python. And then we'll go through some just simple real examples of different assets and see how they compare when we evaluate them with the Sharpe ratio. So first off, we'll just have some basic imports and NumPy and pandas for the data and the simulation, Matplotlib and Seaborn for the visualization, and then Yahoo Finance will be used when we actually get to some of these real market data examples down here. But first, before I actually jump into the code, let me show you what the Sharpe ratio is mathematically so you can get a sense for what we're calculating here. So if I jump over here, you'll see on the left, right, this S is our Sharpe ratio for a single asset. And then what we're looking at basically is the return of that asset, RA, minus the risk-free rate. So the risk-free rate is just anything that you could get on your capital or your cash without taking on any risk, like buying a bond or just keeping it even in a high yield savings account, for example. It's just whatever the world agrees is kind of the default rate that you'll get on cash just by lending it out to a very trusted party like the US government. And then we're going to divide this quantity up here, the numerator, by the standard deviation of the asset's returns. So that would be the volatility of the return. So if you think of volatility as risk and then returns as reward, it's basically measuring the risk-adjusted reward, or how much reward we're getting per unit of risk. That's why it's a ratio. All right, so it's really simple to understand. Obviously, the higher your returns are, the higher your Sharpe ratio will be. The higher your volatility is, the lower your Sharpe ratio will be. All right, so that's what we're trying to do here. So let me show you how to actually calculate that in Python. It's very simple. So we're going to define a new function here called Sharpe ratio. It's going to take in a return stream. It'll have a risk-free rate. We can just set it to 0 by default, but you could also pass in a pretty typical value here. And we'll look at this over an annualized period. So we'll say, there's 252 trading days in a year, but I made it generic in case you're trading a different market. Maybe it's not equities or something like that. So the first thing we'll do is calculate our excess returns just by subtracting the risk-free rate from our returns series. And then we'll calculate the mean, which is the average, and the standard deviation, which is the volatility. And we'll calculate the daily Sharpe ratio as the mean excess return divided by the standard deviation. And then finally, we'll annualize it by taking the daily Sharpe and multiplying it by the square root of 252. And that gives us our annualized Sharpe. So let's see this function in action now. So I'm just going to simulate two simple price series here, or rather return series. And both of them will actually have the same daily returns. All right, let me fix that typo there. But in this case, the low volatility returns will only have volatility of about 1% a day, and the high volatility returns will have 3% a day. And we'll see the impact that that has on their Sharpe ratio. So the lower volatility returns will have a Sharpe of about 1.6, whereas the higher volatility will have a Sharpe of 0.93. All right, so you see the importance of adjusting for risk here, right? Because if we're just looking at returns in isolation, we don't actually see the full picture. And you can see that here as well. Obviously, the higher volatility strategy has a higher dispersion of its daily returns. Now, this is cool because we can test out different parameters here. We could say, for example, what if the higher volatility strategy also had higher returns? Would it have a better Sharpe ratio then? Like, which strategy should you pick? And now you can see with its higher daily returns, its Sharpe jumped up quite a bit, but it's still technically lower than the lower volatility strategy with lower returns. And you might be wondering, well, why is this good? Like, shouldn't I always just take the better strategy? And the answer is it depends a little bit, but usually higher volatility is worse because it means you can use less leverage on the strategy. So a higher Sharpe ratio is pretty much always a good thing, especially if you have a strategy that has a Sharpe over 2. That's going to be a very promising strategy. So now let's actually look at some real market data to see how we can compute this for some real instruments. So I'm going to use Yahoo Finance, and I'll just pull in the last year's of Apple data. And what we want to do is take the close price and then convert it to returns just by calculating the percent change day over day. And now we have a returns column on the right here. Now let's say that our risk-free rate is 5% annually, and then we'll just divide that by 252 to get the daily risk-free rate. And we can calculate our Sharpe using the Sharpe ratio function that we defined before, passing in the returns value, and then giving it a risk-free rate on a daily basis. And you can see here that Apple has an annualized Sharpe of around 0.3, which is, nothing crazy, but it's okay. We can look at Apple's cumulative returns like usual, and we can just see kind of what that looks like, right? In terms of both how it's done over the last year and then what the distribution of returns is. Now let's actually compare this to a couple different instruments. So here we'll do Apple, Microsoft, Netflix, Tesla, and Nvidia. And we'll calculate its returns like before. We get that instantly. And now what I'll do is just loop over the different columns that we have, and we'll calculate its daily returns, annual returns, vol, Sharpe, and pull that into a cohesive data frame. And here I've actually added a little bit of styling to it so you can see very quickly which ones are standouts. So you'll see here that Netflix has the highest Sharpe ratio by quite a bit of a little bit over 2. And that's because it has a very high annual return of 70%. In fact, it's the highest annual return as well. And it has one of the lowest volatilities out of all of these. Now, you might be thinking, well, Tesla's pretty good as a company. Like, I like Tesla. We all like buying Tesla. But here Tesla has, it has a 65% return. It also has a 72% volatility. So its Sharpe is much, much worse. And then it looks like Microsoft really is kind of the most troubled here with a return of like 9% and a volatility that's much higher than that. So anyway, my point is, when you're looking at different stocks, or let's say you're even looking at a strategy, because by the way, I'm showing you everything in terms of single assets here, but you could replace these single assets with your trading algorithm, your trading bot, even your manual trading system, any system where you have a daily sense of what the returns and the volatility are, you can calculate a Sharpe ratio for, and you can evaluate it. And again, the higher your Sharpe ratio, the better strategy it is. The more risk-adjusted returns you're getting, the more you're likely to beat the market. And not just that, but then you can also add in leverage to a strategy more safely, because you know that you're not going to take on big drawdowns or big swings and get margin called. Although obviously there's a bit of nuance to that. Now the last thing I'll show you here is while I have you is this cool interactive viewer. So without getting too much into the code here, when you're running a Jupyter notebook, you can actually add interactivity. So here I've just made a little drop down where you can check out the Sharpe ratio and the cumulative return and the daily returns distribution of the different assets over the time period, and play around with it, see which ones are doing the best, and then see simple things like obviously Netflix here with its high Sharpe of 2.3 is still looking pretty solid, right? Despite some of its drawdowns, we can see that it's pretty steady most of the time, whereas let's see, Microsoft here is just bouncing all around. So you can kind of see just visually how all of these things line up with the Sharpe ratio itself. So yeah, that's it for this video, guys. If you want to grab the code, it will be in the top link in the description, and I will see you guys in the next one.